Hello, today I'd like to introduce you to the pod from Ideal Heating. So, recognising the changing landscape in the heating market, particularly in the domestic heating market in the UK, and the drive towards greater use of low carbon and zero carbon heating solutions, Ideal Heating has undertaken the development of a new heat interface unit to meet the needs of the district and community heating sector in the UK. So what is a heat network? This is a new term for a lot of people, and it's something they might not be familiar with. You can essentially break a heat network down into three larger pieces. The energy centre. This is where you will generate all of the thermal energy that you then distribute throughout the system. So you will have a central energy centre or a plant room where you create all the thermal energy for the network. Second part of a network you can generally regard as the distribution. So this is generally a series of insulated pipes, typically buried underground, that carry all of the hot water that you've generated in the energy centre across a network. And then the third part is the heat interface unit, basically the appliance at point of use inside the residence or the dwelling. And this is a piece of the equipment that's going to be visible to the end user. This is the piece of a network that they will see on a day-to-day basis, and this is what will form the basis of their experiences with the heat network. So when you're talking about heat networks, people might talk about district or community heat networks. So when they talk about a district network, they might be talking about a large area. They might be talking about a whole district or a borough of a particular council. They could even be talking about a whole town. They might even be talking about a city-wide network. If we were talking about a community heat network, they might simply be talking about a network that covers a small number of properties over a very small area. It might even refer to a network that just serves a single building. Generally, they all provide the same sort of function. Their purpose is to provide that thermal energy from an energy centre to the people who need it in the dwellings. Another term you might hear in regard to heat networks is Energy Service Company, or ESCO. The Energy Service Company are the people they could have sole responsibility for the network, right from the energy centre, the distribution network, through to the heat interface units in the dwelling that are providing the end user with the heating and hot water. The ESCO could simply be providing the maintenance and operation of the plant room and management of the network, and then the responsibility for any of the buildings that are attached to that network could lie with the local authority or a borough council or private landlord. So when we talk about heat networks, I think one of the key things that people will often bring into the conversation is the fact that they are energy agnostic. So you can incorporate a number of low carbon heating solutions into that energy centre, or you can have low carbon energy solutions contributing to that energy centre to overall give you a very efficient and a very low carbon solution. So you could have, in the first instance, some traditional gas boilers until the technologies are more widely available or more widely used. The gas boilers could be providing backup to some of the lead heat sources, which are low carbon heat solutions. You could be looking at heat pumps, and that could be air source, it could be ground source, it could be water to water heat pumps, and they can extract that energy from a number of different sources. You could be taking energy from rivers, you could be taking energy from mine water. So anywhere you have a background source of heat which you can run through that heat pump to contribute to the energy in the network, you have an opportunity there to realise a lower carbon heating solution. You could have combined heat and power engines. You could have some biomass. You could have waste heat from industrial or commercial processes. So there are a diverse range of energy sources which can contribute to the low carbon and efficient operation of a heat network. Heat networks are a flexible solution for heating. You don't simply have to apply them to residential properties. You could be using heat networks to serve a number of public buildings. It could be serving factories, it could be serving offices. Wherever you need or have a need for heating and domestic hot water, you have an opportunity there to look at using a heat network. So who might be interested in heat networks and HIUs? Well, government obviously. The Committee for Climate Change have recognised that heat networks are one route to realising low carbon heating solutions in the UK. Councils obviously will be looking at their planning systems and looking at ways in which they can incorporate lower carbon heating solutions into their property portfolio. You'll have housing associations and landlords looking at what benefits it might bring to them and their residents to consider using heat networks. You could have developers looking at incorporating them into the retrofit of a redevelopment or even into new build properties. You'll have consultants and specifiers who want to know what benefits the heat networks can offer them in terms of realising a lower SAP or SBEM figure for their buildings. And obviously, residents and tenants are a very important part of heat networks because they're now potentially going to be receiving their heating and hot water from a new technology. So Climate Change Committee have recognised that heat networks and heat interface units are one route to realising a lower carbon future for the UK's heating system, alongside other low carbon technologies. And heat networks will provide a scalable low carbon heating solution on a properly designed, specified and operated system. So, looking at more detail into a heat interface unit, what actually is it? And you will most likely in the UK hear units described in two similar terms, so direct and indirect heat interface units. There are a great number of different variants of heat interface units, but these are typically the two most common. So indirect heat interface units typically have two heat exchangers in the appliance, and they provide complete separation from the end user, from the dwelling's heating and hot water systems and the network. So some units might be provided with a single plate heat exchanger that indirectly provides heating or hot water only. So it would still be an indirect appliance. You still have that demarcation, that line of separation between the network and the end user. But you might only be serving a heating system, or you might only be serving a hot water system. For a twin plate unit where you have provision for heating and hot water from the HIU, these are comparable to a combi boiler. And I think this is a key point, try and make it more familiar to people who could be moving into properties or could be looking at buying properties on new developments that are served by a heat network. This is not technology that is unfamiliar essentially. When you look inside a heat interface unit, you will recognise quite a lot of the equipment from your combi boiler. And the sort of thermal comfort and the sort of service you'll receive from it is very much the same. The Pod Indirect HIU is a twin plate appliance which provides separation from the network through two plate heat exchangers and gives the user a stable and precise control of their heating and hot water requirements. Alternatively, some systems are now designed to have a direct connection. So you probably see just a single plate heat exchanger which still provides an indirect connection to the network for one or of the other service. So it could be separating the system from domestic hot water, or it could be separating the system for heating. So in a direct heat interface unit, the heat from a network might be provided directly to a domestic hot water cylinder through the appliance and then indirectly to the heating system. Conversely, you might also have the heat from a network might be provided directly into the heating system and then indirectly as instantaneous hot water by the heat interface unit. Both have some form of direct connection to the network, and so both would be regarded as direct heat interface units. In terms of its operation, you could compare a direct heat interface unit to a system boiler. The Pod Direct is a single plate appliance and it provides instantaneous indirect domestic hot water to the end user, and then it has a direct connection for the heating from the network. So what are some of the benefits of using heat interface units? Well, they provide a point of separation or demarcation between the network and the end user. It allows the end user greater levels of thermal comfort and control over their energy usage than if they were directly connected to a network in some instances. For the developer, specifier or landlord, in certain instances they provide a means to meet the standards and guidelines for carbon reductions that are now implied by new building regulations or planning regulations. and it allows the integration of renewable energy sources into the systems as well. This in turn can lead to an overall improvement in the energy efficiency of the systems that they're installing, and hence leads to a better SAP or SBEM rating. You can show compliance with several industry standards in terms of the BEAS test regime for HIUs. You can show RAS approval on a product, demonstrate CE and UK CE approvals, and obviously EMC and LVD testing. All of these contribute to giving the end users, specifiers, confidence that they've got a quality product. In terms of looking at the infrastructure of a building, other than maybe a gas connection into the plant room or the energy centre, for if you're using gas boilers to provide some of the heat source, you won't have any gas installation within the building at all. So whereas on a traditional system where you were installing individual combi boilers into properties, those gas connections are all removed, and so is the requirement for fluing from those appliances from out the building. So obviously you have no flues to run, you have cleaner installation in terms of the services that run through the properties and potentially run through the buildings as well. For the end user, the benefits of using HIUs is they're a relatively low maintenance appliance. Obviously you've got an increased level of safety as there are no gas combustion, there's no gas being provided into your property to serve that appliance. You have no annual gas safety checks. You'd still recommend having them serviced on a regular basis to maintain their optimum operation and efficiency. They also have a compact and space-saving design. So the pod from Ideal Heating, when you look at it on the wall, is very comparable to the size and shape of a traditional combi boiler. They can be efficient to run, and they're very simple to own and operate. There's very little that the user needs to actually do on the appliance in order to ensure that it's operating. Basically just check that it's switched on and check that you're getting heating and hot water from it. And an indirect appliance, as we mentioned before, that are comparable to a traditional combi boiler, provides heating and hot water. And it's very easy for the user to understand and accept that that's the sort of service they're being provided by that appliance. This isn't difficult technology to understand. So looking at some of the core components of a heat interface unit, some of these will be familiar to people who've taken the time to look inside the boilers, and some of these will be new and introduced with the heat interface unit. So one of the core components at the heart of the appliances are the plate heat exchangers. These are generally stainless steel in construction. They provide a very large thermal area in a compact package, and this thermal area is essential for extracting all of the thermal energy from the system and transferring it through into the end user's heating and domestic hot water systems. So plate heat exchangers of this type are highly efficient. They lose very little heat at all. They're also highly effective at transferring the thermal energy from the network when they're properly specified and applied. And they have a pressure capability well in excess of the normal operating conditions on a heat network. Another of the key components within a HIU, generally the pressure independent control valves. So these provide the facility to maintain a stable and accurate flow through the appliance under varying pressure conditions on the network. They can control a differential pressure of up to 600 kilopascals, or to put that into perspective, 6 bar. So if you imagine your car tyres might be pressurised to, I don't know, 1.8, 2 bar, these valves can control a pressure difference between the primary flow side and the primary return side of a network of up to 6 bar. So they're very capable. There's no need for additional costly differential pressure control valves to maintain that stable control of the flow through the appliance. And it allows the maximal primary flow rate through the valve to be limited. So where you have a large system, we have potentially hundreds of heat interface units, and you need to know that each unit is only taking as much flow through it under use as you have allowed for in the design of a system. The valves that we provide in the pod will give you that opportunity to limit the flow rate to a certain level. On the central heating side of the heat interface unit, you'll see a water set and expansion vessel. So the water set is taken from our highly successful Logic combi boiler and includes integrated components that give you a high efficiency circulator, It gives you the opportunity to modulate the pump speed to match your duty on the appliance. It gives you an auto air vent to bleed the air out this heating system. It gives you a pressure relief valve to protect the system, and it gives you a bypass valve and a pressure switch. The expansion vessel obviously allows for heating and cooling fluctuations in pressure on the system, and that's taken from the Vogue combi boiler. Obviously, energy usage is something at the forefront of everybody's mind, and efficient use of energy. And in order to monitor the energy used by your heat interface unit, you have to provide a heat meter. In the pod, we've got a meter which has an ultrasonic flow part in brass to provide a very robust and long-lasting appliance, and it can be wired for M-Bus metering solutions or also wireless M-Bus. The battery life of up to 11 years, and it's produced by a global industry leader in energy management solutions, Landis+Gyr. It's their Ultra Heat model. This is the device that users will see on their heat interface unit, which will give them the reading much the same as the gas or electricity meter might do in the property. This meter tells them their accumulated thermal energy usage. So in terms of mechanical controls that we provide in the HIU, we've obviously got primary differential pressure control valves, which gives us the opportunity to control flow and then temperature through the appliance from system differentials of 50 to 600 kilopascals. And that obviously, as we've mentioned, can be presettable to limit the primary flow rate through the appliance at the appropriate level for the application. We provide a domestic hot water flow restrictor on the domestic hot water side, and that makes sure that the user isn't trying to overflow the appliance and as a result ends up with poor domestic hot water temperatures. We also provide a domestic hot water hammer arrestor, so when people are opening and closing the hot water taps, it's going to limit the amount of noise that they might hear on the system. The central heating pump we provide with an automatic bypass valve in the event that these happen to be installed on systems where all the radiators or all the underfloor systems have valves which will shut down and control flow. It prevents the pump from being deadheaded. We also have obviously the auto air vent there to make sure any residual air in the system is bled out as it's circulated round. And we do have the option to fit a primary credit control valve where these systems are being used on prepay or credit controlled billing systems. And as an option, as recommended in BS 7593, we can provide a system filter for the central heating systems as well. In terms of the electronic control functions of a HIU, we've got fast-acting pressure-independent control valves. These give us precise control for domestic hot water temperature and central heating temperature. We can control the operation of the heating function on the appliance by either switched live or open therm heating controls, and the open therm is compatible with our new Halo Light room thermostat. We can provide weather compensation. We can provide a switchable domestic hot water preheat function, and that's useful where the network wants to use the HIUs to provide facility to keep the network operating at the appropriate temperature. We obviously mentioned we have a modulated central heating pump which contributes to the efficient operation of the appliance in terms of its energy consumption electrically. We have valve and pump anti-seize protection, so certainly where you're on a heating system which in summer periods might be idle for quite some time, the unit will automatically exercise the pump and the valve to make sure that they don't seize or get stuck. So when the user does actually want to start using the heating system in anger again, the unit's always there and always up and running. We do also provide a function for primary return temperature limitation, where the network operator wants to ensure that temperatures being returned to the energy centre of a plant room are as low as possible. That function can be enabled. Where these are being installed onto systems which have underfloor heating in new properties and they're pouring a fresh slab, we have a slab warm-up function which will ensure that the unit is only introducing heat onto the system at a very gradual and controlled rate to ensure that there isn't any cracking or premature drying on the system. We provide a frost protection function in the appliance where there's any chance that the system may be left idle for long periods of time and may reach temperatures where it could be at risk of freezing. We provide a commissioning function for the pressure-independent control valves, whereby the heads of those valves can be automatically driven open and held open for a predetermined period. And this is particularly beneficial for commissioning engineers who might be trying to balance a certain section of a network, maybe a branch on a riser, it will hold those valves open that will allow them to set their flow rates on a particular part of a system, and then they can move on to the individual commissioning on the appliances themselves. We also provide a credit control function, which if enabled will ensure that where the signal isn't available from the credit control hardware or from the billing system, the unit will go into a controlled shutdown. In terms of standards, approvals and codes of practice for heat interface units, there are several areas which are encouraging improvements in the design and efficiency to increase the experience, the positive experience that end users have with heat interface units. So organisations like MENA, the Manufacturers of Equipment for Heat Networks Association, these are a group that's part of the Energy Utilities Alliance, and it's a trade organisation representing manufacturers of the equipment that are used in heat networks, to make sure that collectively the industry is responding to all of the issues and all of the calls for information and improvements that they see. You have bodies like the Building Engineering Services Association, who are trying to drive improvements in the minimum standards, in the testing of HIUs, in the training of people who are dealing with heat networks and heat interface units. You have RAS, the Water Regulations Approval Service, who are making sure that products are appropriate for use on wholesome or potable water systems, and you'll see heat interface units typically carrying the label as a RAS approved product. You have CIBSE, who have produced one of the most comprehensive codes of practice for heat networks in the UK, a document that covers all stages of the design, development, implementation and operation of a heat network, that gives anybody who's interested in them a great deal of information on what are regarded as minimum standards and best practice for heat networks at any stage of their development. And you also, from a consumer side, you have the Heat Trust, who are an organisation who is representing the opinions of consumers. Thank you.